Fusion Mobile, quality e-learning experience on the go.
Structural isomerism. What are isomers? Isomers are chemical substances that have the same chemical formula but different chemical structures. That is, they have the same formula, but when they are represented, when they are drawn, they have different structures. These substances oftentimes have different behaviors, different characteristics. An example is one of this which I'm looking up at right now. The chemical substance I'm looking up, the first one is pentane, while the second one is 2-methyl butane. The first one is pentane, while the second one is 2-methyl butane. The pentane, of course, if we count the number of carbons present is 5, if we count the number of hydrogens present, it is 12. And of course, in the 2-methyl butane, count number of carbon atoms, it is also 5, and count number of hydrogen atoms, it is also 12. But both of them have different characteristics. As a matter of fact, 2-methyl butane is gaseous, while propane is also gaseous anyway, but more of a liquid than a gas. Very volatile liquid. Now, the reactions that alkanes go through include combustion reactions, substitution reactions, and denitrogenation reactions. Now, combustion reactions simply is reactions that when they are burnt in air as fuel, they produce carbon dioxide and water. Substitution reactions is when you react them with other substances such as chlorine. They produce hydrocarbons or halocarbons, that's chlorofluorocarbons or chlorocarbons and the rest. An hydrogenation reaction is when you collapse the bond and release hydrogen, dehydrogenation. You release hydrogen gas from whatever is created. So this equation is showing ethane turning to ethene. Now yes, talking about cyclic alkanes or cycloalkanes, the chemical formula as indicated above. Unlike the regular alkane that the chain is connected, they have a circular, or they connect together all the bonds to form something like a circle most of the time. So that's why they are called cycloalkanes, and they tend to have the same formula as ethane. That is, they have less hydrogen atoms than the normal alkane of their family. Alkenes and alkynes. Alkenes, of course, they have double bond in between them, so they tend to have the formula CnH2n, and of course those are two of the connection of the bonds. And also we have alkynes. Both of them are unsaturated hydrocarbons. You can just go through things been written on the screen, just an extension for the description earlier stated. Yeah, talking about cis and trans isomers, of course, this simply talks about the direction in which the substances, the chemicals, are aligned. It affects the melting point and boiling point temperatures of these substances, but it really doesn't change much in their structure. It changes, of course, since it is an alteration in their structure. It changes a bit of what happens to them. So, aromatic hydrocarbons. Aromatic hydrocarbons are cyclic hydrocarbons, and of course, most of them are unsaturated. Yes, such as benzene, which is what is shown to us in the diagram we have below on screen. That's benzene. You have alternating single and double bonds, and at the end of the day, we tend to have 6 carbon atoms and 6 hydrogen atoms. This is just this exact structural representation, and they do not go through addition reactions at all. They only undergo substitution reactions. They can lose an hydrogen atom for a chlorine atom, or 2 hydrogen atoms for an oxygen atom, whatever, but or an hydrogen atom for an hydroxyl atom, but they do not, they for an hydrogen molecule rather, That's one bond connecting to the carbon and the other connecting to the hydrogen, but they do not go through addition reactions.